see fake review. Then the reviews in all products may purchase a difficult decision for the customer. We want to have an assessment of low or low quality products with good review. Then the goal is to design and implement and construct a system that can help or support the customer in order to have a good product and don't spend a lot of time and provide any rating and a solution to the local industry. Then we want to filter this review. From the literature review, we see different, that's some examples of the different approach. For we see the column of methodology, some online providers of products detect that someone or some groups of the provider of these sites is posting different fake reviews. They identify the IP address and similar pattern of the text, and others use a sentiment analysis or orientation to see if this review is positive or negative. Others use some machine learning techniques or algorithms like string or word vector, make different processing in natural language to detect this review. Others use a group spammers rank, rank, a group spammers rank, relation based on some models in data mining, applying the other techniques and so on. Then our approach is the following. In the previous research, use group spammers rank, the IP address of the people who post reviews, neural network, and the model and our approach is to use, the better is to use support vector machine classifier and then frequency inverse document frequency for the future extraction. This approach is used in multi-language. For the moment, English, Urdu, and Roman Urdu. Then we have distinguished two types of the reviews. For people who verified a purchase and for people not verified or customer who verify the purchase and who don't verify the purchase. And the heuristic is different. For the first case, we have that we take into account the polarity that can be negative, neutral, or positive, and the sentiment analysis. Then, if the rating of the review is bigger than 4, in the rating of 1 to 5, as it's all the markets is established, and the review is negative or neutral, then the review is considered fake. If the rating is bigger than 4 and the sentiment analysis is positive, then the review is considered genuine. And if the rating is equal to 3 and whatever is the sentiment analysis, the review is genuine. And if the rating is less than 3 and the sentiment analysis is neutral or positive, then the review is considered fake. For the non-verified purchase, it is the one of the model of our approach because the other is different. We're running a model showing the incoming slide. What is considered? We call firstly we collect the reviews. Then we pre-processing, remove punctuation, stop word, lemmatization, and the gram technique. Then we apply the feature extraction and apply support vector machine classifier. This is the best. We apply 4 classifiers. Then the architecture or the model considered the data set, for instance, the gel extracted from gel hotel review. The preprocessing is, as I say, we eliminate the stop words, we consider only lemmatization and bigrams. Then we apply the vectorizer of feature extraction, and we try in this classifier review classification into class as truthful reviews and deceptive reviews. Then the results, compare with the others approach that we put in the analyze in the paper, is better than the others techniques used. We use it 80% of our reviews for training and 20% for testing. From the case of hotel reviews data sales, we have 100 genuine reviews from 3 advisors, and we have the half for positive and half for negative. For the Google and Roman review, we have this one. We use from gel reviews data set, deceptive reviews and genuine reviews. And we equilibrate the genuine with the deceptive reviews. In the order database, we use 200 and genuine and 200 deceptive. And for the Roman Urdu, we use the same database, and we made the translation manually from the English dataset. The system design includes the web-based application. It's a web-based application. It takes the URL of Amazon, Dallas, or Flipkart products. It separates the fake reviews from genuine ones, and it provides a genuine rating for the user versus genuine reviews. This is the process for any user to utilize this system. You introduce the URL, either Amazon, Full, or Dallas. And the process just come. They have the trusted review. The tools and technology used is the programming language Python, the web framework the Django, and the database MySQL, and from DNA, HTML, CSS. We have a video. This is where we work. As a conclusion, we see that if we design and implement an evaluation assistant to support people in the finding the best quality product from online provider. The system provides a minute rating and a solution to the local industry. The phase review detection, e-commerce and in all domains, multilingual, English for the moment, Urdu and Roman Urdu. The analysis base support vector machine classifier, time frequency, inverse document, and sentiment analysis. The approaches designs two kinds of reviewers, verifier and non-verifier features.
Finish?
You have some question?
Some question? The speaker?
What are the output values? Output values. So you give like the actual rating and the rating that the product has on the internet. And you also put, I think I saw like positive comments, negative comments, and then fake comments.
Yes.
Evaluations.
An evaluation.
Okay.
Equal number of the positive and negative. And genuine or non-genuine for the training process. And then we use the 20% of all the database to test if the system verified or classified well the review.
Okay.
Another question?
I have a question. What is the objective to work with Urdu? If apparently there are not sites.
No, it is a language used in Asia.
Yeah, but
Urdu and
even
Urdu Roman.
the sites in Pakistan are in English, no?
Almost all people, but not all, like here, not all the people know English if they don't go to the school.
Yeah, but of course here there are many sites
Normally,
in Spanish.
when the people go to the school, they learn English, but all the time they prefer to use their language. Lee, for instance, the professor Lee, has a Duke computer in China. By side, you can see she uses it and she knows English. But this is the reason because this is local industry for Pakistan or for India. And there exist other countries. I don't know, in Thailand, but some countries of Asia use Urdu and Urdu Roman.
Because the script is very different, no? The characters, no?
Yes, it's different character. Yes, I have. This is an example of the database. This is an example of the database. We don't understand Urdu and Urdu.
That is like
Roman. Yes, we can open the Urdu and Urdu open. We have, this is one of the database we use it for the training. You can see.
Okay, the Roman Urdu, it's only the translation to
Yes.
the phonetic?
Yes.
Okay.
This one.
Okay.
Yes, we can see all the content. And the other is for the English. And the other is the English from which it translates manually one by one.
And that was used for training the support vector machine?
And we use it for classifier. The better, the most precise was SDG. Support vector machine, SDG. Support vector machine.
Other question?
No?
Okay. Thanks the speaker. Tool to solve nonlinear algebraic equation systems. And the speaker is Gerardo, Cesar, Velez, Lopez.
Good morning. Excuse me, my English is bad. I am a student in INAOE. My name is Gerardo Velez. The title exposition is a tool to solve nonlinear algebraic equation system. The content of the talk consists in 5 points. I will begin with motivation. I will show some theory, the result obtained, and finish with conclusion. Our team focuses in obtaining collision-free path and apply a robot. In my case, it is in robotic arm. The method we use deterministic. We use the homotopic continuation method. Therefore, it's necessary to solve system of nonlinear equation. The layers develop this application. We begin to explore with the Newton-Raphson method, which is commonly used to solve systems of nonlinear equation. But it is not that this method has disadvantages. So alternative methods based on Newton-Raphson have emerged. The method attractive in this case. This method is second derivative. Another method used in the homotopic continuum method, which consists in altering the nonlinear function with no parameter. We implemented Newton homotopy. In this case, it's mathematical represented with line. The computer grading method is used to generate an initial point in complex nonlinear. To program this mathematical algorithm, the GNAL library was used, which is based in C++. The library allows use manipulate equation and extend this capitally to develop various applications. GNAL allows fast manipulation of large integer and rational owing to the Selenium library. This application was developed in Linux, Ubuntu. This schematic shows the file setting on the main screen when it started. In color red were common notions for all numerical methods. In green, I showed a homotopic continuation method. In blue, the configuration parameter gradient conjugate method. Now, I will show you an example. I consider a nonlinear system with the function. The following is shown in yellow: number of functions, independent variables, the select numerical method, the function and initial point, in this case 1,1, and time and consumption time. The result is shown in purple. Here you can see the value of the root found, the iteration number, and the error which you found them. Meet the error placed. As in the previous example, now 12 systems of nonlinear equations were solved. The result and times obtained were compared with Maple. The conditions under which the test performed are these. The computer is normal. The times show where the result of evaluating each system 20 times and then everything. The result. In this case 7, our application obtained a different solution for the data of Maple. In the study case 12, our application did find the solution and Maple did not. The computation time obtained were lower in our application. In addition, there was a lower consumption RAM. In conclusion, I will say that numerical methods selected in this first stage were good. The selection of the GINA library produced good results in the consuming of the computing time and RAM. In addition, they used the C++ language allowed to develop this application different operating systems. A well-embedded system, for example, Android, iOS. We will continue exploring numerical methods that help obtain the solution to complex systems. A more intuitive graphical interface will be created, making it easier to operate. Thank you. Any questions?
Any questions for the speaker? Questions? Okay. You mentioned some problem with the Maple, no? For the case of study 12, no? What's the problem? Never finish, or
it's correct,
or some problem with the memory, or
Maple consuming much more RAM. In this case, 12 case is no solution. How is it called?
but with your tool, you find the solution. Your tool finds the
Yes,
solution.
yes, our application and find the solution.
Okay, and your application was developed in C++?
Yes.
C++.
All.
You can compare also with MATLAB, for example?
MATLAB is good in numerical, algorithm numerical.
Yeah, for numerical solutions. But you are doing the same, no? For numerical.
Yes.
You are trying to find numerical solutions. So.
I don't know comparison with
Yeah, because Magma, it's Magma. Maple, it's okay for symbolic calculus, no? But I think it's not very good for numerical.
in our case, or a team for work with Maple. Is the tool cercano.
Any other questions for the speaker? Give thanks to the speaker. Yeah. The third talk is a computational interface to automate cognitive memory test and synchronize with measure EEG signals. And the speaker is Fanny Zavala Santoro.
Thank you very much. Good morning, scientists and assistants. I'm going to present this work called the Computational Interface to automate cognitive memory test and synchronize with EEG signals. We heard before. We carry this research by Tecnológico Nacional de México in Morelia, and in collaboration with one of the most important health organizations in our country, Instituto Mexicano del Seguro Social. Okay, the computational interfaces have been used to many uses in biomedical applications, and this one is for automate the a specific memory test. So the synchronization of the interfaces with EEG signals, it's for obtain important data, specifically during this task defined by the test, has or allow to examine and analyze more deeper those data and their behavior. In order to automate this memory test, we have developed a graphic user interface to synchronize the memory test with the graphic user interface. Well, the methodology implemented over here, it's, wait a minute, I have my pocket guide. Yeah. Okay, yeah. Okay, yeah. This interface is designed to do specifically incidental and intentional memory. And this allows us to detect deterioration of the cognitive process. And the most important on this work is the time markups put it on the software to synchronize the signals with the interface. And that shows the stimuli or the instruction shown on the screen. The cerebral activity synchronized with the memory test can show us also the neuronal activity in different circuits or neuronal circuits. Over here in this figure, we have a diagram and how the test is carried on. And we have two devices. The first one is for acquisition of the EEG signals, and is put it on the patient or on the participant using the international system 1020 for the EEG signals. And in the meanwhile, the EEG has been read. We have the first time markup, which indicates that the acquisition has started. And then, for other hand, we have the memory test run by LabVIEW, in the same time. And we have another time markup when the test starts. And those yellow lines indicates instructions or stimuli given to the participant. So here is the main screen of the interface, and this is very important, or is the main idea of this work, because all of those times, perfect. those times over here is the basal measurement for the patient to see the behavior and then their neuronal circuits measure. And those 60 and 30 seconds are automated. During the whole test, the whole timeouts are automated. Before this, it was held manually. So imagine. Well, the patient only have to follow the instructions on the screen. Every continue button is a markup also. And this is a very funny test because the patient have to solve this maze or labyrinth. And the first task is to mentally solve the maze. That's it. This is for incidental memory. It hasn't any kind of instruction related to memory. The patient doesn't know that he's going to remember something else. Just solve the maze, and then the next instruction screen is requested to remember the path in the labyrinth, watching only a blank screen. The next task, the participant is requested to solve the same labyrinth, but now using the mouse and drawing a line for the path that used to solve the maze labyrinth, and then observe the labyrinth during 30 seconds without any other instruction. And this is the interesting thing because 14 objects are shown on the screen sequentially, asking the patient or the subject if it was on the labyrinth or not. This is also incidental memory, and the time markup going to indicate us if how was the response in a specific moment of the answer of the patient. If the object was in the labyrinth, we have to put it on the right place over here. After that, the labyrinth is shown again for another 30 seconds, but now is requested to memorize or remember the objects where was placed on it. Okay, and after this task, the subject is requested to repeat the same task before, but now with 20 objects. We had 14 objects, but now we add another 6 more to intentionally force the codification in the brain and search which circuits are involved in that process. When the patient finished this task, the test is over, and we have some observations over here. Before this synchronization, the memory the same memory test, cognitive test, was carried on about 60 or 90 minutes because the examiner had to write manually the answer of the patient. And this automated test is completed in 30 minutes. And this is very, very important for the neurologist. Without delaying the continuity of the test protocol in medicine, they have to follow strict protocols to validate the method. So these allow to have continuity in the test. The synchronization between EEG signals and the memory test is in real time. Before this, they have to match the data with the test in offline also, but with no certainty that it was in real time of coincidences in the exact time markups. Here is the data sheet generated and making the match. Here we have the time markups. The original file is a TXT file, just synchronized by software with their time, respective time markups. And here we have the task or the objects shown on the screen, and the answer of the subject, if it was right or wrong, it depends. The position, if the answer was right or wrong also, and if the object was new or wasn't. So this data is analyzed by the neurologist in the department, research department, INS. And there is a LabVIEW interface which match or synchronize the EEG signals, which are the lines in black and white and blue and red. And the yellow lines are the time markups to indicate a task, an instruction, begin of the basal measurement, or a sequence, or a specific task. Okay. Okay. And we have these main conclusions. The stimuli automatically timed and neural response synchronize improve the duration of the text, obviously, and the accuracy. The results do not depend on the examiner experience or ability, because we had a lot of problems with the examiners doing the test, because it was very, very new. We had a lot of human mistakes. Okay, the computational combined with different type of cognitive test is an alternative to analyze the neurological status of an individual, because currently they are run mainly, or the most important, with RMI or tomography. Those are invasive, and this kind of interfaces or synchronization give us the same information but with a non-invasive method. Signals related with coding and learning processes are easily identifiable with the time markups. That thing was impossible before, because we didn't have exact time markups during the test. And finally, synchronized responses can be analyzed extensively offline. The next work for this research is to analyze using the time and frequency domain methods to find some patterns, but this is the next step for this. Okay, this is the reference. I know this is a very tiny font, and consult. This is all people involved. Okay, thank you very much.
Okay. Any questions? Okay. Any questions? Okay, I have one. Okay.
What was the goal of the research implementation?
How long?
No, how was the goal of the
Okay, of the implementation of this interface. This is a very important question, because this research corresponds to a need to diagnose neurological diseases like Alzheimer's disease. And here in the UAM, Universidad Autónoma de México, is held another kind of study related to autism in children. It's it's kind of cognitive test. So that was the reason. This is the main.
You don't show any results,
Because
discussion about the results.
Because this was only the development of the interface, and the test with about 100 patients gonna be carried out for the next months, before December, I think, but it's recently developed. with the requirements, with the specific requirements and the modifications that the center, the research center requesting us.
Are you using some commercial data acquisition interface?
Oh, the unique commercial is lucky because the EEG device, that one, was developed in the Instituto Tecnológico de Morelia. It's a portable device. It's synchronized with LabVIEW by Bluetooth because the green grass, I don't remember the brand right now, but the commercial brand is huge and it's difficult to
The accuracy is the same, or
No, this is
better?
it's a pocket version. This is like maybe a cell phone, a little bigger.
And the quality of the data is okay?
It's perfect. Actually, that device, I have it in IMSS, using it. And it's using also by the Universidad Michoacana, and it's Department of Psychology Research. It's the same device. Yeah. We're looking for
Your own device?
yeah, they have their schedule for using it in different kind of cognitive tests.
I think the only problem is because the license for LabVIEW is very expensive. No?
Yes, and actually we're looking for translate all this code into Python. Because I think it's going to be held over the next year. Yeah, but now we have a LabVIEW running with one license, academic license. Yeah.
Any other question? Give thanks to the speaker.
The minimum that is this is coupled with the light, actually the photons, and the free electrons here. So, particularly when I say I'm interested with biosensing surface, so what I'm doing here. So this is a gold surface. Here I have antigen here, and I call the first one's SPR curve here. And when I do the injection, so I measure the interaction of the protein binding, for example, and I saw the displacement of this SPR curve. So that's my idea. Actually, that's my motivation. The work is divided and with the introduction, I have the physical model, geometry or numerical method, boundary condition, aspect ratio of square root, procedural discussion and conclusion, and my collaboration. So, as I said in my beginning of my presentation, I am using thin films on the substrate. So when I measure the protein binding, I have a sensitivity of nanogram per square millimeters. So, but that when I use metallic nanoparticle or nanohole arrays, I increase or enhance the sensitivity to atograms per square millimeters. Metal field perforated by nanoholes constitute a power for platform for surface plasmos resonant biosensitivity. So let me explain what about the work. What I do is this is traveling optical transmission by periodic array in subwavelength apertures. So and this I have a 3D presentation of this work by So, and when I coupling the light with these apertures drilled with the metallic films, so I can see the enhancement of the transmission. For example, this is for gold. This is for silver. So I can see the enhancement about 6, around 300 nanometers. So that was my motivation, and also by using plasmonic biosensing, using this swivel arrays of apertures in on metallic surface. So let me present here about the Maxwell equation. You know, this is the Maxwell equation, and I have the constitutive relation. So I was using particular Ampere laws and Faraday laws. What is the experiment that I simulate with? So we consider a TM transverse magnetic mode with respect to C, TM set mode. So, and I fixed the wavelength. That's because in my lab, I only have one wavelength. I don't have different wavelengths. So my idea is, what is the aspect ratio that I would continue with my talk. So if I can simulate before I drill on metallic surface, because my goal is biosensing application. So I lighted on the normal incident to the gold surface, and I did with a single 1D slit. And I use the diameter with this 200, 150, 120 nanometers, and the depth will be 300, 200, 150 nanometers. So the 2D Maxwell equation that describes this proposed TMC that is lighter on the normal incident is here. So I do that in 2 dimensions. Let me remember that this is gold and this is all air. And actually my idea is in the future is to have water, for example, or PBS, or protein here in this aperture or slits. So what I did here is I applied G algorithm. So in this case I have this 1D electromagnetic wave. So I have electric field, magnetic field here. So what I did is discretize this by using G algorithm. So this is in 1D, this is in 2D here. So you can see here the G space lattice, where N is the temporary steps, what I say here. T is the time increment, K is the discrete position with the domain, and I say delta C lattice space increment. In this case I have a G space lattice because it's in 2-dimensional. And what I'm doing here is I have in 1D space Maxwell equation through the finite different time domain, and I have the amperes and Faraday law equation. So I discretize here, and I have here the G algorithm in 2 dimensions. You can see this is the Maxwell equation, and this is discretized, and I using this EC mode. Don't confuse the with depolarized, but in particular we are using this this kind of wave. One of the the boundary condition is, and I use 1 millimeter, 1 millimeter. So what I do in that the field computation domain is limited in size, but will be large enough to enclose the slit of interest. In this case, 1 micrometers or 1 micrometers. We restrict our perimeter by absorbing boundary conditions that call ABCs. They actually I'm using perfect match layer that is they're using a material that absorb nearly all the incident field. In particular, I'm using this is type of more magic step absorbent frontiers that is called for. This is for the right, this is for the left. And the aspect ratio that we're doing in the beginning of my talk, what I'm saying is this R, aspect ratio, that this is depth divided by diameter. So I have this 12 simulation that we present here. Actually, I shown here the MATLAB code in 1D. So if somebody is interested, I can share. My result is what you can see here is we are you can see the tangential electric field is the distribution, and I use, as I say, I fixes the wavelength 300 nanometers through the nanoslit. So the diameter is 120 nanometers, and I use the variation. For example, this is 200 nanometers, 200 nanometers, 100 nanometers, and 50 nanometers. So you can see here that it's not extraordinary optical phenomenon, but I move from the another one that's 150, and you can see here in the up in the slits the extraordinary optical transmission here inside of the nanoaperture. Actually, the nanoaperture I'm doing, I try to say like eye guidelines. It's not actually in the simulation, but in order to you can see better, I draw on the here. So actually you can see the extraordinary optical transmission in here, that is B, is 200 nanometers of depth, and with a diameter of 150 nanometers, and actually in this way. But what happens if I move for 200 nanometers? You can see here that in the first one, this is 300 nanometers, that the aspect ratio is 2, and the another one is aspect ratio 1.33. That is, you can see the extraordinary optical transmission. In this table, I presume that when I use diameter of 100 nanometers and depth of 300 nanometers, I can see the measure of the center of the slit, 1.2 increase, 20%, yes. And when I use 200 nanometers and with this depth, 200 and 150, you can see the extraordinary optical transmission. So, so my conclusion is, actually the main result of this research is that the extraordinary optical properties are controlled mainly by diameter, D, and the depth T of the nanostrip, which are critical for coupling the wave and the localized surface plasma in the slits. And the enhancement of the tangential electric field EC is about 1.4 times, and is localized inside the nanosleep region, very interesting for using for plasmonic biosensing. And also, it's observed that when D increase, the extraordinary optical transmission phenomenon doesn't occur within the nanocavity region due to the coupling of the TEM is in a way with the localized plasma inside the nanoshells. So let me finish with my collaborators and some students that were involved in this work, but this is only part of the simulation, but actually we are working with plasmonic biosensing and actually with a sensor application in Leal. So thank you very much.
Okay. Any questions?
Any questions?
Any question?
I understand that you are developing a biosensor and the enhancement of the plasmon resonance inside the cavity or in D. And what will happen with some molecule localized in the place? Maybe it will be reduce the distance for the size of the molecule or the protein, for example.
That's a good question because actually we are trying to do in the lab is actually you mentioned that if I have here the protein, you know, and what happened if, and actually that's my motivation because the electric field will interact with the protein, so will change this transmission, and it will be fantastic for to increase the sensitivity of the sensor.
Another question? Could you use something, some other method besides gold?
Yes, I can use, for example, silver. And another method, I use gold because it's biocompatible, and I can with a protein because I'm interested with protein. So that's the reason.
Biocompatibility?
Yeah, because I want to anchor the protein on the surface of the gold surface. So that's the reason.
Now your simulation was performed in MATLAB?
In MATLAB? Yes, I didn't mention that it's in MATLAB.
What kind of algorithms are you using to solve these Maxwell equations? Because finally you have a lot of differential equations, partial differential equations.
Yeah. Actually, it's in this G algorithm.
The algorithm, that is an numerical method?
It's a numerical method.
Okay.
So, yeah, G algorithm is a numerical method.
The performance of MATLAB solving this is okay?
Actually, at the beginning we have some problem, but at the end we contrast with another group, with another simulation, and actually we did in 1D first, and then we moved to the 2D simulation. So, but we did.
Other question? Okay.
Okay.
Even thanks to the speaker.
Thank you very much.
The last talk of this session is given by Aldo.
Thanks for waiting. Sorry for the delay. I'm going to present here the multi-phase flow simulation. I want to tell you that this is just a small part of the work that we are doing and that we are developing, and I will try to give you a scope of the work that we perform here in the staff and in collaboration with UAP, Universidad de Puebla. So this is the content of the presentation. I'm going to talk to you about microfluidics because maybe you haven't heard about this technology, the motivation, the methodology that we follow, some results, the acknowledgement, and future work. I don't know how many of you have heard about microfluidics here. It's a new area. When I talk about a channel, I mean a physical channel with a width, a depth, and length. So this new science, is the study of systems that can process small amounts of liquid in channels in order to perform chemical reactions, for example, and some other physical phenomena like droplet formation. This is very useful in many areas and biological areas nowadays. And we can perform a lot of actions in these systems. And as you may know, we exploit the physical phenomena of laminar flow. We can create micro mixers, parts, and we can integrate all these with microelectronics and microactuators. So some of the most useful areas of this science is paper microfluidics, that now is in development, and drop formation, that is some of the things that we perform in this project. There are many entrepreneurs that work with this technology. Where microfluidics come from? Microfluidics comes from microelectronics and microfabrication, photolithography, molecular analysis developed in the 80s, molecular biology, if you remember the project Human Genome, and for a motivation of the United States government, an agency that develops biodefense. They want to develop devices that their troops could use in the field in a battle to detect biological threats, for example, and they have a very big budget. So with all this, we can use this technology to develop, as I tell you, small sample volumes manipulations. We can perform many actions with this, splitting, sorting, separation, encapsulation, mixing. The chemical reactions become less dangerous. You can perform a chemical reaction that maybe is dangerous in a big volume, more safe. And we can perform automatization of these reactions. And of course, because all of this is automatic, the results are more similar to other results. Okay, our main goal in this work was the development of, as you see here, okay, some of the experiments that you perform in the biological area are very expensive because of the reactives. So if you perform this in silico, in a computer, is more economical. So if you don't have the resources, this could be a very good solution for your work. I will show you later some other experimental results that we could perform, but we start with a simulation. So, sorry. What is the general simulation process? We use finite element method to simulate the process of the microfluidic drop formation. We use console as a software, and the general process is depicted here. We use first the liquid characteristics that are involved in the simulation. So you need to perform first the liquid rheological characterization. After that, you define a geometry in the software where you establish initial conditions and edge conditions, mount sleep conditions, velocities, inlet velocities, and more. After that, you perform discretization of the geometry, and this is called a mesh. And you finally solve with some of these commercial softwares, and you obtain the results and the interpretation of these simulations. Depending on the characteristics of your liquid, you use two several liquids that has to be immiscible one with each other in order to form this phenomena that is called drop formation. This is the result of the simulation. You can see here with a numerical solution of the Navier-Stokes equations what is done here. So this is just the part of the simulation. After the simulation, we start to implement this in a system that we could use to perform this physical phenomena in a microchip, or called lab on a chip. We use a chip that was developed here with photolithography here in Cesar, and we use some pumps, a sequel made by us with some 3D printing parts and some parts that we developed to connect the pumps with the chip. We use LabVIEW to program these pumps. It's a syringe pump that is controlled by this software on a computer, and we can inject precisely control the liquids into the chip. After that, this is part of the fabrication of the microchip. Here with photolithography, we perform we develop these chips, and as I tell you, we create a master mold with a channel of 10 micrometers wide and 15 micrometers deep. We can see here in this video the profilometry study of the characterization of the channel. We can see here in real time how the tip of the profilometry is drawing actually the channel that we are seeing here in the picture. So here is the central channel, and the other two are the other channels for the liquid. After making the mold, we need to reproduce these channels, because as you can see, they are not real channels, they are protuberant. So we need to use a biopolymer to copy this. Basically, it's like a jelly. And this is the geometry that we develop here, as I tell you. And this is the central channel here. This is a close-up. Well, after this, we need to reproduce these channels, as I told you, with a polymer it's called polydimethylsiloxane, and create the inputs or the inlets for the microchip. We conduce these liquids through the pipe to the chip. Finally, we were able to create the physical conditions as you saw in the simulation. This is called a laminar flux flow or jetting condition. As you can see, we have here two inlets, and we produce a very tiny jet at the center of the channel. And this other condition is called the drop formation condition. That is actually what we were looking for in our simulation, and it's very thin. You can see here how the microparticles of oil are created inside the carrier flow that is water. So what are the results? You can see here the implementation of this chip in our laboratory in Puebla. And as I tell you, we use here two inlets for the liquid and the central liquid. this is the physical phenomena that we depicted in the simulation, and we can produce very precisely and control micro droplets of mineral oil inside water. What is this useful for? You can use these microparticles as a microreactors. You can use it to produce chemical reactions inside each droplet, or you can encapsulate cells inside the droplet. And you can create droplets inside the droplets to produce multiple emulsions. So it's a very useful technology, as I tell you, and we are seeing here in real time how these microparticles are coming out from the chip and from the pipe in a flask in the laboratory. And this is the microscope observing this pipe inside the flask. That is what you saw in the video. And this is other video in real time. We are performing here the production of these microparticles. In a moment you will see how these microparticles are formed here through the microscope. And we were able to see what's happening with this microchip. Here comes. The camera refer is approaching to the objective of the microscope, and we can see here how the microparticles are coming out from here. It's very thin because it's very clear, but you can see how the particles are formed here, one by one. Can you see it here? Coming out. And this is in this video we can see a little bit better. Again, this is the design created here, and we can see a little bit better the formation of these droplets. This is very fast. We are using a fast camera to catch up the formation. These other videos are the transport out of the chip through a pipe of these particles once they are created. We can see it here. And as I tell you, we can create particles inside particles with this technology. Imagine, for example, that the inlet, the internal part maybe could be cells, proteins, or another compound, a drug, for example. And these are the results. And as I tell you, this acts as a microreactor. We can create nanoparticles inside the microdroplets. And these are the results. We create nanoparticles of chitosan, and we encapsulate protein, EGG protein of human protein inside these nanoparticles. As you can see, they are very uniform in size and shape. These are some of the results, and we can see how here is the protein encapsulated with 10 characterization, and contrasting or putting in a different site. This is the result of the same nanoparticles created by the batch method in laboratory in a flask. So we can see the results very different from the use from the fabrication of the nanoparticles with microfluidic. Yeah, and these are some results of AFM characterization. And in conclusion, sorry, this is in Spanish, but we could able to simulate the phenomena and to create the device and all the things that we need to conduce the liquids and perform the experimentation in a microfluidic chip. There is nothing, future work. There are many things that we can do with this technology. We can create multiple emulsions, make libraries of components inside a memory, a liquid memory, for example, to perform chemical reactions. we are working now in a project that will be able to create a sort of organ on a chip. And this is not going to replace a human organ, for example. This is going to be useful to produce experimentation in a model that is better, or that is better suitable than a mouse, for example, because you can use human cells instead of animal cells, and with better results. There is nothing to thank to CONACYT and all the people involved in this project that is going on. We are working on this, and we hope we will obtain better results and more things. Thanks.
Any question? Questions?
So this is, you mentioned that microfluids you are using for synthesized nanoparticles, but in this case you are synthesizing polymer. But what happens if you are interested, for example, in semiconductor nanoparticle or metallic nanoparticle? It's possible to do that?
Of course, it's possible, and it will be better. You will obtain better results. Why? Because working with biopolymers is very hard, because they don't have physical characteristics that are always the same. For example, we work with chitosan. Chitosan is a biopolymer that has changed in size from 300 to 375 kilodaltons. So you have several sizes in the change of the polymer. So if you are working with materials, for example, silicium or not organic materials, it will be better result, because you can control precisely the quantities that are involved in the chemical reaction, and of course it will be better. And the bibliography of the literature shows an improvement in nanoparticle fabrication with inorganic compounds better than organic ones.
Okay. Any other question? Okay, so we finish the session.
Thanks.
I will talk about harmonized variant based on a novel synthesizing approach for constraining numerical optimization. I'm from CDTech, another school of Instituto Politécnico Nacional. And this is an overview. We're going to see an introduction and an explanation for harmonizers, an explanation of our variant Calyx synthesized harmonizers, the experiments and results, conclusions, and future works. Okay, what is optimization? Optimization is the process of sears under given circumstances. A mathematical formulation for constraining numerical optimizations, abbreviations in notes, is mean or max objective function or a set of objective functions subject to a equality and inequality constraints. Also, all the variables are limited by amounts. How to solution synapse? There are many methods to solution synapse. One of these is mathematical programming methods. Another, which highlighting these topics, is meta-heuristics. And meta-heuristics can be classified in three groups: evolutionary algorithms like differential evolution or genetic algorithms, swarming intelligence like colony optimization, artificial colony, artificial bee colony, and firefly algorithm, and metaphor-based approach like killer whale, hydrological cycle, gravitational algorithms, And this is the algorithm worked harmonizers. There are many algorithms that they show here. Harmonizers is an algorithm based on musical compositions and consider treasures when the musician composes music. The first is a previous generate harmony that is a combination from the harmony memory and adjustment on the previously mediated harmony by change of its notes and a randomly generate new note. A harmony is a combination of a music notes that emerge as a sequence. And harmonies are changed during the composition process. This adjustment is simulated by a harmonization algorithm. Harmonization algorithm was proposed by Dean in 2001. Harmonization is an implementation algorithm that only generates a new solution by cycle. And he see the solution generation, rate pitch adjustment, random adjustment, and the harmony memory is update. The new solution is only accept is this solution is better than the worst solution of the harmony memory. The best one solution say is better or worse according to the rules. The rules are a handling constraint for constrained problems. The rules say that if we have two individuals, if one is feasible and if both are feasible, we select the better fitness, or in this case the minimum value of objective function. And if we had one individual feasible and other not feasible, we select the feasible. And if we had two not feasible individuals, we select the lesser constrained relation sums. The constrained relation sum is calculated using these formulas, and for reduce the computational complex of the problem, equality constraints are converted into inequality constraints using a slack that is commonly 1 per 10 upper 1 minus 4. In literature theory are many variants of HAs, import harmonizers that had deterministic parameters, adaptive parameters, and others have self-adaptive parameters, or introduce new form generations. HAs has proved to be an algorithm that produces good solutions with a low computational cost. So this is important to improve new variants, to improve this development, because their low computational cost is a good thing for this. It's a good approach for this kind of problem. And here is our variant. It's based on a modern musical composition. Actually, musical composition uses a synthesizer that accelerates the music composition process, because they can emulate and include notes, different notes from instruments or for waveforms, like square wave, sawtooth waves, and triangular waves. And these harmonies can be filtered, can be added and filtered using a synthesizer to generate new harmonies and new sounds. And we try to codify this synthesizer in an algorithm, and we start with the best global solution and modify this best global solution using the knowledge by the other RB's solution, the second B solution, the third B solution, the fourth B solution. And also we added a dynamical parameter to increment, to develop the exploitation exploration on initial iteration and exploitation on final iterations. The knowledge given by the second best and the third best is determined by the harmonies of the geometric waves used and a filter. The filter guide or cancel the effect of the other best, or the second or the third best nodes. This is a pseudocode for synthesis harmonies algorithm. We added a new way to compose an harmony, that is an adjustment by a synthesizer. This adjustment is given by a probability. The probability is given by the RSA and the opposite of RPA and RS. For experimental results, we have we use the benchmarks for the CEC 2006, and the criteria of simulation, the parameter of simulation, was given by mega fair comparison against other algorithms showing in the literature that use this parameter. And here we select a triangular way for our algorithm. 30 independence rules were selected per each problem, and we make a comparison between our modification, the normal edge algorithm, and a modification called S8 Mod 2 that you also use the best global solution. This is the table of results. Here we highlight that we found with SH algorithm a better solution than the given in the original paper. And for this table is so difficult to see, and here we summarize the results. SH versus SH algorithm versus H8 wins 33 times, get similar results in 5 times and worse in 4 times. And against H mod 2, it's better 6 times, get similar results 7 times, and it's worse 9 times. H algorithm is the best for this problem. This problem has something in common, that is a very complex problem because the raw value is low. The raw value is the relation between the feasible reason and the global space of search. And also all of these problems have adapted constraints. As a conclusion, we had that the codified synthesis approached the search process by modifying the best global solution with the knowledge given by the R-based solution. SH has a better behavior when solving scenarios with active constraints and lot values. This represents, as I mentioned before, very complex problems like real engine problems. And as I mentioned, SH achieved a better solution for problem 15 than the reported in the benchmark. For future work, we propose use a different geometrical ways. Here we use a triangular way. In future work, we can use a square and sawtooth way to evaluate the phase of the selection of the way in the results. And the implementation these synthesized codes with another variance to evaluate the effect and produce a synergy that improved harmonization algorithm. And finally, apply, as I mentioned before, apply SH for solving hard optimization problems like real engineering problems. Thank you. Questions?
Some question? Questions?
So, in what engineering problem you are thinking that you want to apply this?
Actually, this algorithm has been proven with we are working in future course and forward mechanisms for tracking path.
What is your main motivation to try to find another heuristic? Because now there are a lot of bio-inspired.
As I mentioned,
there are many.
there are many, and inspiration in different cultural or animal behaviors. And harmony search is, as I mentioned, is a good algorithm that produces good results with a low computational cost. This low computational cost is important to evaluate the solution of synapse and improve this algorithm is good work for get better results using a less computational cost.
So for example, what is the difference in performance between this and normal genetic algorithm or differential evolution, for example? Because I think the computational cost is given basically by the objective function.
Here the computational cost is evaluated by the number of function evaluations that an algorithm used to generate these results. Against differential evolution, in this kind of problems, H6 is not a good algorithm, but in other case, H6 produces better results than genetic algorithms or differential evolution. It's so difficult to find an algorithm that solves all kind of problems because the no-freelance theorem explains this.
This is only a global optimization, no?
It's not global, it's constrained numerical
Yeah, but
optimization.
this is not multi-objective.
No.
It's many objectives. We say that, no, global optimization, because you have only one function.
Yes.
It's
One
not
object.
many, no? It's okay. Okay, so this is based on something more, no? Okay. Okay. Any other question? Okay, we give thanks to the speaker again.